Hello guys, welcome to my YouTube channel Anil Physics Academy. In today's lecture, we will learn about resolution of vector. What is resolution of vectors? Resolution of vectors means writing a vector in terms of two or more than two vectors. For example, let there be a vector A. We draw a vector B here and we draw a vector C here. So from triangle rule of vector addition, vector B plus C is equal to vector A. So we can write vector A is equal to vector B plus vector C. So we say that we have resolved vector A into vector B and vector C. Likewise, let this be a vector D and this be a vector E. So vector A is equal to vector D plus vector E. So we have resolved vector A into vector D and vector E because from triangle rule of vector addition, vector D plus vector E is equal to vector A. Now let this be a vector F. This be vector G and this be a vector H. So here we can write vector A is equal to vector F plus vector G plus vector H. And we can say that we have resolved vector A into vector F, vector G and vector H. So this is the resolution of vectors, means writing a vector in the terms of two or more vectors. Now let there be a vector A in the plane of this board. This is a vector A in the plane of this board. And now let there be two another vectors. Let this be vector B and let this be vector C. And we are asked to resolve vector A in the direction of vector B and vector C. So what we do? From here we draw a vector. From the tail of A we draw a vector parallel to vector B like this. First of all we draw a line parallel to vector B. And from head of A we draw a line parallel to vector C. Let both of these lines meets here. So this can be a vector parallel to vector B and it can be written as lambda B. So and this can be vector parallel to vector C and this can be written as mu B, where lambda and mu are real numbers. So we can write vector A is equal to lambda B plus, here is C plus mu C. So we have resolved vector A in the direction of vector B and vector C. Now we will learn how to resolve a vector in x-axis and in y-axis in xy plane. Let us see how can we do it. This is xy plane, this is x-axis and this is y-axis. And let this be origin. Let there be a vector A. We have to resolve vector A in x direction and in y direction. From head of A we draw a perpendicular to x-axis and similarly we draw a perpendicular on y-axis and let this be a vector. Let this be A, B, C and let this be vector. So from the parallelogram rule of vector addition we can see that vector A is equal to vector OC plus vector OB. Vector A is equal to vector OC plus vector OB from the parallelogram rule of vector addition. So we name the vector OC as AX and vector OB as AY. Here vector OC, which is AX, is the component of vector A along x-axis, and AY or OB is the component of vector A along y-axis. Hence, here we resolved vector A in along x and y axis. And what is the magnitude of vector AX, which is the component of vector A along x-axis? Let this angle be theta. Vector A makes an angle theta with x-axis. So AX is equal to A cos theta and AY is equal to A sin theta. So we have resolved vector A along x and y axis. Now here vector A was given and the angle made by vector A with theta was given. So we resolved vector A along x and y axis. Now if we have given the x and y component of a vector and we want to find the vector and its direction, magnitude of the vector and its direction, how can we do it? So let here Ax and Ay are given. So A is equal to, what will be A? A will be Ax square plus Ay square root. And what is angle theta? Theta is equal to, tan theta is equal to, here we can see that tan theta is equal to, see, this is Ax, this is Ay. So this is also Ay. So tan theta is equal to Ay by Ax. So theta is equal to tan inverse Ay by Ax. So if the component of a vector along x and y axis are given, then we can find the magnitude of the vector and its direction. That's all guys for today. Thank you very much.